Okay, so now we're going to deal with a very interesting type of capital budgeting question that's going to touch upon the net present value, but we need to use a different approach because we're going to be looking at different projects with different lifetimes, different timelines. As you can see on the screen, we have 4 different projects with 4 different like life expectancies. And when you deal with stuff like that, you got to use the EANPV approach. And this is exactly what this comprehensive question will do for you. This is exactly what this video would show you. This is what you may see on a final exam. You may see this on a project or an assessment. And hopefully this video can essentially give you the tools and resources needed for you to feel like you could do this on an exam yourself. You could feel like you understand how to break down a complex wordy question like this. So terrible introduction, but hopefully this helps, and let's jump into it together. So you work in the accounting and risk department of the National Basketball League, the NBA, and Adam Silver has staffed you with evaluating the following mutually exclusive expansion projects. So as you can see here, we have projects, right? We're going to look at all of our columns. We have cities, we have initial investments, we have NPVs, and we have project lives. Okay, so at first sight, this question looks kind of straightforward, right? You have different NPVs, and you may think that, hey, I will choose a project with the highest NPV, and that's going to be the best project for us to choose. In this case, you would say, okay, well, let's take the Stingers of Vancouver. And then, of course, you would say that the worst project perhaps would be the Monsters of Montreal. But the thing is, we need to look at a very specific portion of this question, and that's the project life. Some projects are going to last longer than others. And this is actually going to lead us to a very important takeaway. Well, of course, projects that last longer or that have a longer lifetime, well, they have more time to literally recuperate their initial investment. Whereas projects that last a smaller amount of time, or they're going to have less time to recuperate their initial investment. In other words, to yield a high NPV. So you got to think about that. And what we're going to need to do is we're going to need to put all these projects on the same lifetime, on the same period. So we could find essentially their annual, okay, so their effective annual NPV in this case. In other words, they look at the equivalent annual NPV, that's how they call it, but you get the gist of it. We're trying to standardize them on a 1-year basis. And that's why the EANPV approach is way, way, way better. And it's the right approach to take. On an exam, you cannot use the NPV as a tool to make a decision if you know that they all have different lifetimes. Okay, so that's what we're going to need to do. We're going to need to use the EANPV approach. All right, and on the second portion of this question, they let you know that, hey, our discount rate is going to be 10.28%. And we want to know, as you can see, which project, and I'll highlight it in red, follow my little tradition here, is we're going to highlight our mission. In this case, our mission is to figure out, well, hey, which project should you recommend to Adam Silver? So knowing all this, we need to start with the first step. And I'm going to zoom in a little bit such that I can write it down for you to kind of see and understand, is we're going to need to highlight, well, what the heck is the EANPV formula? And essentially, what do I need to plug in there? So you're lucky, I have it on standby with me, and I'm going to write it right now on the screen. So the EANPV approach is something that you're going to have to do for every single one of the projects. And you're going to use this formula, okay? So let's highlight it and let's write it together. So the EANPV formula, okay, as you can see on the screen, I'm sorry if I'm writing slowly. I wanted to make it at least somewhat legible. It's a pretty interesting formula, okay? You're going to take the NPV of a project, so we could call it NPVI, so of any given project, and you're going to divide it by the following. You're actually going to divide it by a fraction. It's pretty interesting stuff. So you're going to divide it by 1 minus 1 over 1 plus k to the power of n, if I'm not mistaken. Okay, make this a little bit nicer. And this will be over k. All right, so this is going to be your EANPV formula. Okay, so you're going to have your NPV of a given project, and you're going to divide that by a fraction in itself. So I could technically maybe even put this in a different colorway, so it's really, really distinct for you. Oh, sorry about that, everybody. If you're watching this, I apologize that the screen moved to no man's land, but that's just, a little technical difficulty happens. So we're going to put it like this. So we're going to have NPV of a given project over the following. So that's how you find the EANPV. And in this case, you should notice by now, we're going to be doing it for for 4 different projects, right? For project A, project B, and project C. And we're going to try to figure out, well, what's the EANPV for every single one of these projects? And then the greatest one, we're going to choose that one. That's going to be the project that we're going to recommend. So this is my first time ever doing this, all right? It's my first time ever doing this, but I'll actually add a small context before we start solving this together. What I mean by first time ever doing this is my first time doing this specific question. Of course, I have the solutions because I made the question myself, but we're going to solve it together. That's what I meant. One thing that I would like to note, though, is that, of course, there will be 2 things that will be changing every time we plug in this stuff into our formula, this stuff. Okay, the NPV will be different per project, right? Every single project, you're going to plug in something different in their numerator. And every single project, you're going to plug in something different for their N. So this will be the project life. Now, of course, every single project will have a different project life, or else we wouldn't be using the EANPV method. Okay, and then K, well, K is going to be a constant because in this case, we're going to be looking at the opportunity cost of the company. Okay, so just to give you a little bit of context. Now, we could go ahead and write it for every single company one by one. Yeah, we'll go like that. So in this case, let's jump in and let's try to figure out what's the EANPV of project A. Of project A. And just to be super comprehensive, once again, I hope you understand that because I'm lazy, I'm going to call, the Nordics of Quebec City, project A, the Monsters of Montreal is project B, the Supersonics of Seattle, project C, and the Stingers of Vancouver, project D, just to make it simple. Okay, so we're on the same page. All right, so in this case, I'll show you an example of how we would go about it. We would zoom out just to find all of our numbers. So we know that the NPV of project A is 1.75, and we know that the N of project A is 18 years. So we have those 2 numbers. Now I'm going to be a little sneaky person. I'm going to put just 1.75 rather than a million, right? It'll be the same thing. This 1.1028. And if my memory is correct, this project will last 18 years. I'm going to have this over essentially 0.1028. And that's going to give us the NPV for, well, the EANPV for project A. So what I'm going to do is I'm also going to kind of just copy this immediately such that we have a framework to use for every single project. So let me just do that super quick. I'll do it another time because we're going to be looking at a few different projects. I could put this one like here, I guess. And this I could erase. Kind of doing this on the fly, so hopefully you could respect that I'm taking a little bit of my time just to figure it out. Okay, so of course the stuff on the right hand side of the screen, we're going to change them to EANPV B, EANPV C, EANPV D, just to make that super clear. What we're going to do now is we're going to actually plug all of this in within our formula. Okay, so we're going to have 1.75 in our numerator. We're going to have another fraction in our denominator, which is going to be 1 minus a fraction in itself. This is hilarious. 1 over 1.28 to the power of, in this case, 18. And that's going to be over 0.1028. So, me, it's my first time doing it, so I will like to try to be as comprehensive as I can. So 1.75 divided by 1 minus 1 over 1.028 to the power of 18. And that's going to be divided by 0.1028. That should give us 0.21722. So we're going to have 0.21722 as our EANPV for project A. Now, if we look at project B, okay, we're going to look at that. We're going to look at project B. We're going to use a different color. We could even leave it like this. We know that the initial investment, or the NPV, sorry, is 1.55. Okay, but we know that this time, the lifetime is 25 years. And all else remains the same. Now on an exam, this is annoying. This is a annoying process. You don't want to have to go about this. You know, it's long, it's hard, but you want to get it done. And these are easy points. So I'm going to go ahead and plug this in within my framework as well. So instead of 18, I will have 25 as my exponent for the number of years. My n will of course be different. Just to be super comprehensive, I guess I'll highlight this as well for y'all. So notice how we have 1.75 and 18 here. Here we have 1.55 and 25 here. So we're looking at different projects, okay? Just making that super duper clear. So here our EANPV for project B will be slightly smaller. So we're gonna have 0.17.44 periodic. So that's awesome. Now we could look at project C. And in this case, we're going to have 2.045. And we're going to have 12 years. That's awesome. 12 years as our decision. So once again, you're going to plug all of this in within your calculator. Now, of course, I'm going a little bit faster because I don't want to annoy you and I want to make sure that the time I'm giving you is precious and valuable time for yourself. So in this case now, once again, we're doing the same framework, but we're just changing our inputs. So 2.045, that is correct. We're going to have 12 years. We're going to have project C. That's going to give us a EANPV of 0.30425. So notice how this is a bigger value. 0.0. And now we could look at project D. So in this case, you know that we're just changing, of course, the little notation here to let it be clear that this is a different project. Our NPV will be 2.95 and our N will be 20 years. So we could go ahead and plug all of this in. 2.25, our N will be 20. And this gives us an interesting amount as well. So this gives us an EANPV of, so I guess we could write it here, of 0.35. 315. So in this case, if you highlight every single one of these, I guess we'll highlight them in a different color. So 0.17, 0.21, 0.17, 0.30, 0.35. Well, we clearly see that project D would be the best project. But I want you to just think about it for a second. Although we could have made that assumption at the very beginning, the thing is that it wasn't a clear decision. Because if I would have changed this value here to call it 2.5, right, $2.55 million, we would have a different answer. And in that case, our project C would have been the best decision, which is why using the EANPV approach is a valuable approach, because it kind of de-alienates everything, okay? So that's why this is very important. So in this case, we know that project D would be best, okay? But still, I want to take a step back. Please, I hope this is clear. If we were to put our project, right, for project D, if we were to put the NPV to a different amount, call it this amount here, okay? If we were to put it at, call it 2.40 or 2.48, 2.50, we would have a different decision, okay? In that case, project C would be the best project because it would yield the highest EANPV, okay? So that's something to just really have in mind. And I hope by running through the different methods that we looked at here, it was clear. And that now you kind of know what is expected from you on an exam if you are prompted, if you are required to solve for a EANPV. And if they don't ask you, it's really important for you to be able to understand that when we have different projects with different project lifetimes, okay, so they have different expiry dates, different maturities, it's important for you to understand that I cannot compare the NPV of these projects directly. I need to standardize them to a equivalent annual NPV. Okay, so hopefully that was clear. Just trying to give y'all some tools to help you just learn this stuff in a more human, I guess, interactive and different way. Learning shouldn't be static, and a lot of what you have out there is the same thing repeated. So hopefully this could be a new set of tools that inspires you and that shows you that, dude, you didn't do that, that you can do really well, and that I believe so. If a fool like me is able to understand this, I am confident that you could run through this with no problem. So yeah, hopefully this helps. I'll see you in another video. Au revoir.